our mask says, no, this is the important region. And using this region, it is classified to the one class 1, which is Sunday. Hi, my name is Changkyu. I'm in Tromsø, UiT Machine Learning Group, and I'm very honored to give this presentation related to my recent works and with some preliminary results. So the title of the talk is Information Bottleneck-based Interpretability Method in Multi-Frequency Marine Acoustic Data. So yeah, the content have threefold. So first, I would like to introduce briefly about marine acoustic data and its deep learning applications. And second, the motivation toward explainable AI. And then our proposed method based on the information bottleneck. So yeah, marine acoustic data. So I've been working with the marine acoustic data for my PhD project. And the data looks like this. So yeah, these data are also called multi-frequency echo sound data, since they are collected from the echo sound on the boat here, where the boat sailed on a designated area based on the target species, something like this. So yeah, and the data that I'm working on is targeted for one fish classes, which is called sand eel. Please forgive me for the short explanation of data due to lack of time, but there is a talk that I gave to Visual Intelligence Seminar regarding the data, and this talk is available on our YouTube channel. So please visit. Yeah, we have only 72 subscribers now, but yeah, I hope we have more. Yes, so yeah, we have been working to apply the steam learning method to marine acoustic data, especially based on the computer vision method. And here are the papers. So yeah, there's one paper from Olaf. There is a fully supervised segmentation method, and there is another paper from me and Olaf and other people. It's about semi-supervised patch classification method, and now the next work is kind of integration of these two works. It's a semi-supervised segmentation method, and they are now in review. Today, I would like to talk more about the patch-based classification, because so the patch is to create patch, we split the full echo sound data or marine acoustic data in a regular grid and classify each pixels. And the main advantage is that the neural network architecture can be much lightweighted compared to segmentation architecture, and of course, it's easy to train. And also, it's important for practical purposes, since we might have to train the model on the boat. So, and we are using the data that is collected in real time. So in that case, we might have some limit in accessing the computational powers and so on. So that's the reason why we focus more on this patch-based classification. And in the right-hand side, you can see the small patches that's sampled from the full echo sound or marine acoustic data. Here is a 32 by 32 sizes, where we collect them in 4 different frequency channels, so the depth is 4. And when we train this model in a fully supervised method, then it usually achieves approximately 80% accuracy, so which is quite good, satisfying result in this domain. But we need explainable AI. So because even this deep learning method makes some good prediction, but we are not able to know what is the criteria of the decision, especially to align with the conventional analysis method based on the intensity here or energy measured in the echo sound data. This deep learning method should be able to pick up some region in the patch that influences the prediction. Also, for supervised learning cases, we somehow apply the handcrafted labeling criteria based on the heuristic information. So this figure in the middle, This one is the example. So in this small patch, there is a pattern here. I'm quite sure this is a fish, but this patch is labeled class 0, which is the background. And the reason is that the labeling operators apply some heuristic criteria, and according to heuristic criteria, these patches should be considered only background because there are only too few pixels in this patch. So yeah, let's move on to our proposed method. So our strategy is quite simple. So here, this is the conventional supervised neural network, prediction neural network. So if you have input here, then it will make some prediction with 3 classes. And in addition to this, we introduce another explainer neural network here that create the mask based on this input. Here, the mask shows the region of interest for the prediction and the Hadamard product of between these two, input and this mask, will be processed in the prediction neural network, and then it makes some. Then we can measure. We can make some prediction based on this some Hadamard product between these two, some masked input. Yes, of course, this prediction neural network is very easy to train. This is a supervised learning setup. But how we can train this explainer neural network? So how we can create the mask without any labeling? So here we introduce the information bottleneck idea that, and the idea is to train these 2 neural networks simultaneously using a loss function suggested by information bottleneck. So here, I, or mutual information between T and Y, means here T is a masked input and Y is a label. Yes, they are involved in training this prediction neural network here. And on the other end, the explainer neural network is somehow trained by this mutual information, so between the input X and the masked input T. And yes, as you can see, we want to maximize the mutual information between T and Y while minimizing the mutual information between X and T. And here the beta is regulates the impact of this mutual information between X and T to train the whole learning process. So to give a bit more explanation here, the mutual information, we want to minimize this. So of course, if this mask is all equal to 1, then it just creates just exactly same input even we do this Hadamard product, and it doesn't make sense. So we want to create a mask that shows a brief representation of input, and still we want the masked input to achieve a good prediction performance. So that's the main idea. Okay, let's have a look at this formula a bit more. So here, the mutual information between T and Y, we want to maximize it. And it means that it's just simply computed by minimizing the cross-entropy loss. Oh, sorry. And this mutual information between X and T. So one easy solution is to do it using Kullback-Leibler divergence loss, but also there are some variational methods. But today I want to recommend you to use this deterministic method based on matrix-based reduced entropy. This is a paper, and yes, it works really, really well. Very, very easy to implement, and yes. So yeah, if you're interested, just have a look at it. Yeah, I will show you some preliminary result. So here, if you see the patch bar, the bright region is the masked input, and the dark region is just discarded input. So thankfully, the fish region are bright is very bright. So it means this mask somehow learned to focus more onto this fish region. So I'm very happy with this preliminary result. And one thing that I want to emphasize that, so this is the patch dimension. It is by the heuristic criteria, it is classified as 0. But our mask says, no, this is the important region. And using this region, it is classified to the 1, class 1, which is Sunday. So it make, in this case, it make a better prediction. And overall, this masked input with a very, very brief representation, it achieves 76% accuracy, which is quite positive, also positive in this line of work. Yes, so yeah, this is the take-home messages. So we leverage the information bottleneck idea and train 2 neural networks simultaneously. And explain a neural network, create a mask showing the region of interest in the input based on the mutual information. And the prediction neural network makes prediction using the masked input T. And deterministic method for mutual information between X and T, it works really well. So also the codes are available. So and it's very straightforward to include your code. So I highly recommend this. Yeah, last but not least, thank you for your attention, and I'm happy to answer your question.